Today, let's talk about uniform circular motion and centripetal force. We've examined a lot of linear motion up to this point, whether horizontal, vertical, or at some angle, but there are a lot of objects that follow circular paths of motion. This type of motion is accompanied by an entirely different set of equations, so we have to learn this if we want to approximate the equation of the planets, as well as a wide variety of earthbound objects. Consider a Ferris wheel, as the wheel turns the cars exhibit circular motion because they revolve around a single axis of rotation which runs through the center of the wheel, perpendicular to the plane that contains it. The cars move around this axis with this constant radius, so they trace a circle as they move. Since a circle is the set of all points equidistant from some central point. To describe the speed of the car, it is common to discuss the tangential speed because the inertia of an object causes it to try to maintain a straight line path. This is the speed of the car along the tangent line at the particular instant. If this tangential speed is constant, we will call this uniform circular motion. This tangential speed will depend on the distance of the car from the axis of rotation. If you place a sticker on the wheel very close to the center, it will complete one revolution in the same amount of time as one of the car. But the sticker will travel just a short distance that you could trace with your finger, while the car travel much farther all the way along the edge of the wheel. Since speed is distance over time, a shorter distance covered in the same amount of time must mean in lower tangential speed. This seems counterintuitive since the wheel is one object, but that's why we can also discuss velocity, which we'll learn about later. The uniform circular motion of the car happens because of the constant centripetal acceleration towards the center of the wheel. At any given moment, the car has a velocity vector that is tangent to the wheel, and while the magnitude of velocity will not change, the direction is constantly changing, and any such change and velocity can only happen due to some acceleration. The centripetal acceleration will always point towards the center of the wheel. At any given moment, the car has velocity vector that is tangent to the wheel, and while the magnitude of this velocity will not change, the direction constantly changing, and any such change and velocity can only happen due to some acceleration. The centripetal acceleration will always point towards the center of the wheel. This is what produces the circular motion, as though the car is always trying to move toward the center of the circle but never makes it there because of its tangential speed. Centripetal acceleration is given by tangential speed squared over the radius of the path. So this value would increase if the car were to move faster, and if it were to sit closer to the center. We know from Newton's second law that if an acceleration occurs, the must be the sum force present to produce it, and centripetal acceleration is generated by the centripetal force. Centripetal force is a simply centripetal acceleration times the mass of the object, since F equals ma, so we can describe centripetal force by simply adding the subscript c on force and acceleration, or it can be given by m times tangential speed squared over the radius of the path. This represents the force that must be applied to produce the circular motion, like amount of force that must be applied to spin a ball on a string and a circle around your head. If the centripetal force that points toward the centripetal perpendicular to the tangential velocity were to suddenly vanish, and the event that you were to let go of the spring, that the object would simply move along the tangent line. So hello everyone, this is the question. And let's answer this. First is FC equals MV squared cross parentheses and R. Then FC 0.50 kg cross parentheses 5.0 meter per second, and then cross parentheses 2.0 meter. So that's the ano. And let's answer that. Calculate. 6.30. So that's the answer. And that's all. Thank you.